Hello, and welcome to another session of me working on drakon renderer. Today we'll be adding some interesting things to the rendered diagram, namely the lines connecting the icons. I took the liberty to go ahead and add something from my previous backup branch to the render all function. Render all takes a collection of positioned icons and it produces a diagram out of that. So today, let's just focus on drawing a styled line that would just go somewhere. So the render all function is taking a collection of positioned icons and not the graph, meaning I only have edges and not the vertices. If we went to the terminal and see how drakon renderer presents the directed graph, that is the diagram, we see that we have, we do have vertices, but we do not have edges, meaning we do not, in this function, have the direct access to how the icons are connected. So we'll get to that. Today, let's just devise a way to draw a styled line. So we want to just draw a styled line down. Let's use this. It's not going to be translated. And what we should get is just a default line. Let's see how it looks like. Yeah, and it just goes down. Or you know what? Maybe a quick change of plans. Let's not worry about the style. Let's worry about substance for now. So let's try to propose how we could turn the collection of edges into those rendered diagrams. So I think I have an initial idea how to do that. Let's do this. For now, we have this function render all, which renders all positioned icons. Let's write a new function, render single, or you know what, it doesn't really matter. That takes a type. I don't want to specify what that's going to be, so let's just call it an A. And it is going to return a diagram. Okay. Or better yet, it's not going to have any input, and it's just going to return a diagram. This way, the function render all is going to be unchanged, and I could combine it with just ABC, not having to introduce, yes, I will purchase it eventually, thank you, not having to introduce any modifications to how actual icons are rendered. So what I'm thinking is we could have two rendering passes. One pass renders the icons and another pass renders the connections between icons. Let's see if we can do that relatively effortlessly. So if we go to main, instead of calling just render all, we would do render all, but also, oh, sorry. With render ABC. I hope that should work. Let's see. So we're hoping for the same result. Okay, it's written. Okay, let's do this. Will this work? And maybe this dollar sign is not even. Let's see. No, that would be too nice. Okay, so here we're preparing to render the SVG file from the positioned icons diagram and the connections diagram. Okay, we're getting places. And we run it just to make sure we're getting the same result. Yeah, we're still getting that line. Beautiful. Okay. So now what we want to do is take a closer look at this. This is a pretty printed directed graph representing the diagram. So the first pass only was interested in drakon icons. As you see, vertices in the directed graph are not positioned. The positioning happens after the icons get represented as a directed graph, meaning the vertices, they're helpful, but not for positioning the connections between icons. What is going to be useful when it comes to positioning is the edges. So an edge is a link between two and not more, in this case, vertices. So you see that if we have, say, icon 1, it has one dependency, which is that icon 2. This is sort of an edge between icon 1 and icon 2 is going to be represented as so. Icon 1 is linked to icon 2, like so. And icon 2 is linked to 3 and 4, and so on and so on. So we have a number of edges, and let us try to translate that edge into positioned icons. So in order to get the coordinates of the icons to be connected. Okay, so this function ABC will change, or let's call it ABC prime. And this function ABC prime will take one positioned icon, which is the start of the connection, another positioned icon, which is the end of the connection, and it will return a diagram representing the line that connects the two. Okay, so one positioned icon, we would have to deconstruct it. Here we have something that would be very useful in this instance. So this is icon number 1. This is icon number 2, or the start of the connection, end of the connection. So let's call it position icon 1, x1, y1, and here position icon 2, x2, y2. Now we're going to try and form a connection between the two using the v2 type. Okay, so here it's an offset, so it's probably not going to be perfect, but let's just for now do this. X2 minus x1. And here y2 minus y1, and let's not translate it. This should compile, but it doesn't. Oh, I forgot a prime. You know what? That's true. I don't believe we'll have a good use for the positioned icons. We are only interested in their coordinates. Let's just double check if I'm using the right terminology. Pascal record construction. It's fine. Syntax. I'm going to keep calling it a deconstructor until somebody shouts at me. Let's run it. So this should render a line. Let's see what kind of a line. Oh, it's shouldn't render a line because it's not called. Now, let's go here to ABC. This is going to be interesting. So, positioned icons. Let's take first two positioned icons. Let first, second, let's deconstruct positioned icons as a collection positioned icons. And here, let's do first, let's see if this builds. Oh, non-exhaustive. That's fine. That's fine. We'll get to it. Eventually, we'll be dealing with all positioned icons. Here, I just want to get to. And keep in mind that I'm just taking the first and second. They don't have to be connected. I'm just being lazy at the moment. Ultimately, we should be taking arguments for the ABC prime function from the directed graph, because directed graph represents the connections between icons, and a list of positioned icons does not. Positioned icons just represents laid out icons. I mean, they have their dependencies, but figuring them out would be kind of tricky. I'm hoping to achieve that just scanning through directed diagrams edges. Okay, so let's run it. This should render something. Let's see. Surprise. That wasn't a huge surprise, was it? Let's do another experiment just to triple check that this is working fine. Third. Let's try to connect second and third. Yep. Yeah, so this is what worries me. It should, I think it shouldn't be from offsets, because that just draws a vector originating at 0, 0 and then gets translated. I wonder if we can do, instead of from offsets, I wonder if we can do like globally positioned XY coordinate to XY coordinate connection. I think that would be better for us. Oh, I think we're looking for this. Let's try to replace from offsets with from vertices. From offsets, is here from vertices. So now we can delete ABC. We don't need this anymore. We can rename ABC prime to just ABC. Change this. And let's see how this function is getting called. So here, vertices, it's a P2. And we're getting a stroke line for free, line color for free, center. I'm not sure what this is. Padding, okay, it's good. So a vertex is P2. Do I have a P2 constructed anywhere here? I do. So if I'm not mistaken, from vertices, should take map of P2 applied to a collection of two tuples. One is x1, y1, and the second one is x2, y2. I think this should work. Right, really curious how this is going to look now. Yes, that was easier than I thought. So let's just take a closer look at this line. It does look good. Okay. So technically, let's call it render single connection. And here, render single collection. And I think we're going to wrap it up for today, or for now. And next time we work on this, we need to figure out how to get positioned icons from the graph. The graph is a directed graph of icons. Do we pretty print it? Yes. So here, collection of pairs. Edge icon 1, 2. Or let's use Haskell tuple pseudo syntax. Edge icon 1. Edge icon 2. So we'll need a function that takes a graph it's directed graph. Let's make it full screen. It takes a graph. Or again, let's use pseudo syntax or pseudocode. And turns them into a collection of tuples. Something like this, where edge icon, or maybe even not, takes edges and it returns a list of positioned icons. Then, yeah. Returns a collection of positioned icons, because icons are not the same thing as positioned icons. Something like this, but I'll have to think about this a little bit. I don't want to rush into writing something that's just not resonating fully. Needs to be simple. But I think we have a plan for the next session. For now, I'm very happy with this. We have a connection. It's not perfect, but at least we learned how to draw a sample line over the rendered icons in, let's call it the second pass of the rendering. So I'm pretty happy with this. Thank you very much for your attention and for your patience today, and I'll see you in the next one. Bye.